fundamentals course. And at first, we have done already this introduction. You have already mentioned that we have here exploration geologists, we have resource geologists, we have geophysicists, we have researchers, and data management people too. So this means that we have a lot of things to talk about. Of course, doubts are going to arrive, so it's normal. If you want to go back to any kind of step, we can. So I'm going to talk a little bit more now about what we are going to do as an agenda. So at first we have talked a little bit those introductions. Now we are just going to mention exactly what it is Leapfrog. And Leapfrog is a 3D implicit modeler. So what implicit modeling also means? What is the fast radial basis function? That the implicit modeling is totally based on the fast radial basis function. Who is Sequent, the producer of Leapfrog, and also what is the part of Sequent and Bentley that are together? A little bit of the Sequent solution. So as we had mentioned today, we are using Leapfrog Geo and the plugin extension Edge. So we are going just to talk a little bit about the interoperability of all the solutions of Sequent and a little bit of the course outline, additional training options, and how to contact us on support too. So you must have already done now your Sequent ID, and this is the way that you are going to connect with every kind of solution from Sequent, which makes things pretty easy, because if you want to also contact the support, I'm going to show you, but it pretty easily you can contact the support through the software. So you're going to use your Sequent ID that is attached to your email, and is going to work in every instance that you need inside Sequent. So for the support, for the license, and for the administration and everything else. Also to be able to enter on the courses that we have available online. So now let's talk a little bit uh, more in a more detailed way what is Leapfrog Geo. So Leapfrog Geo is a 3D implicit modeler. It allows us to do a quick construction of models directly from various sources. Those sources can be also drill holes, but I know that is a misconception of Leapfrog being just for drill holes, but it's not how it works. We can also input topographic information. We can also input just points informations if we want. We can insert sections from GPR and all of kind of methods that we may want to use. And if you want to input your essays without your drill holes, you can also do that. As I had mentioned, we have the imports of points, so it's possible to do that either. Polylines, limits, and everything else that you can draw on GIS or any GIS software, you can import to Leapfrog. So if you are working with GIS and you are a little bit afraid, like, can I change the things of to 2D environment to the 3D environment? Yes, you can. So we are going to perform this a few times during this course, but it's very important for you to be aware that it's possible. So as you can see in this image that I'm showing right now, this image right here was totally constructed with historical data. So what that means? That means that we can catch all informations that sometimes we can find even for free. So this information that we have right here, it's from the government of Canada. So we can take the DTM information. We could take the topographic information, the DTM, from the USGS government website for free. Of course, that it doesn't have that much accuracy, but it's a first start, very important for prospection. And one thing that I wanted to mention is just a pretending scenario that after we have done this project, we could show that to our investors or to our managers to keep prospecting on it. And now we have a new LiDAR campaign that was able to get more information from the target area. So pretending that the target area is the A. Now you will want to focus just on that, and you can do that. So you can adjust the height of this section right here to be more accurate with your new data now. So we are going to talk about this between today and tomorrow because we are going to construct our model, our geological model, and then we are going to receive more data. So in this little data that we have right here, we have two phases, a phase one of drilling and a phase two of drilling. This is because I wanted to show you the scenario of an ongoing project. So for instance, you need to plan the first drilling, you do the first drilling, and after you do the first drilling, you do all the interpretations attached to it, and then you can construct the plan for the next drilling, and then you're going to receive the data from the next drilling, and afterwards you will need to do your open pit or maybe underground mine. So we are going to talk about those steps. Sorry, I am a little bit cold today, so sorry for the coughing, but now let's just talk about the capabilities that we are looking for here. So the Leapfrog engineering for us to see how things work. So you will be able to see the processment time. If we have an error in the processment, how we can see this error, how we can insert the data in a good way for us, don't have troubles when we are analyzing that. Also, the domain modeling. The domain modeling is something very important for us to understand that we can have categories as data in general. We can have categories and numbers, and we can do the both of them together and do a domain for that. And this is the domain modeling. So for instance, you have the lithology where your R is happening, but you know that on the within this lithology, you have domains with a bigger, a higher grades. You have this from your essays. So you can do your domaining on this 3D modeling. And this way you will have the volume, which is very important for us to do all the calculations around it and also to do the resource estimations, of course. The numerical modeling that we are going to get on the second to the third day. And the numerical modeling is where we are going to dive in a little bit on edge too, because this is where we are going to get our estimations, our interpolations, and everything that has to be with the numbers in our project. So the visualizations we are going to check because it's possible to combine models. So we can do domain modeling, we can do just the geological modeling, we can do our open pit modeling, and then we can combine this all together because when we are doing a project, we know that this happens. So we are always updating our data and always getting more data that need to have a new analysis. So after that, how we are going to do our block models that we are going to talk on the third day and fourth, how to share, and also the options that we have for the sharing and visualization of sharing that are very interesting. So now I just want to speak a little bit about the difference between the explicit and the implicit. So, sorry. So on the explicit modeling, Michael have commented right here that he had already used Voxy. So when we are talking about the Geosoft and Oasis montage in general solutions, we are talking about implicit modeling. Also, when we are talking about Datamine, Vulkan, and other softwares, we are talking about explicit modeling. And what is explicit modeling? As you can see right on the images, we will have these wires of interpretation. So we have these wires that are basically a polyline that is drawn on a cross section, and those wires are connected together to do the explicit modeling. And what is the problem with that? First, you need to already have an interpretation of what you are seeing. So this way, you are not using your model to visualize. You are visualizing to do your model. And what we are trying to get here with Leapfrog is the most of information that we can get with our data. And for that, we must be able, sorry, we must be able to use different sources and different methods. So what that means? That means that we must be able to use different variables and to also do some implications on the interpretation of that. So the interpretation on the implicit modeling, that is the one that Leapfrog uses, is totally separated from the digitalization process. What is totally different from the explicit modeling. So this way we can have informations of structural data, lithology, all the categories that you want to insert as something important for you on your modeling. You can input all the numbers that you want to select for it. So if you already have a cutoff number, or if you already have a range number that you want to see or you want to calculate, you can already do that and use it as a variable. So as you can see right here, we can have this way a way better accurate kind of volume generated for our R. These volumes, they doesn't need to be exactly for your R. So I don't know if we have here any engineer, geotechnician engineer, but in general, the geotechnicians also need to domain the geotechnical domains. And you can also do that by integrating all the data here. So if you have the information, the structural information, your information from hardness, you can already do a geotechnical domain right here. So all of this is commanded by the RBF technology. So is the rate basis function. This is basically this is a function that if we talk about it mathematically, you will probably recognize it, or anybody here that had done the basic course of engineering. But when we input that on the programming, we can have this kind of function that is a little bit easier for the compute for the computer to be able to process. So what that means? That means that we have this function that is continuous and is getting all the variables that we are selecting to be important. So now let's just talk about the data inputs so we can get on and already open our project too. So the data inputs are everything that we will be able to insert in our project. So the elevation grids, shape data, we can insert right here. The geophysical data, we will be able to insert that. But one thing that is very important to be aware, we cannot do the convolutions here. So if you want to find out the magnetical susceptibility and change that to the magnetical of the place, you will use Petrel or any kind of or other convolution geophysical software. When we are talking about visualizing this data, we can just import that to the geophysical data. So if we are talking about GPR, if we are talking about any layer of gamma spectroscopy, we can import this directly. The only thing that we cannot do is the convolution here. So when we are talking about structural data, we can insert this structural data as lines and as points. We will see the tiny disks and how we do that.
Hi, Julia. We cannot use deconvoluted data means if the data we have already deconvoluted, we can use it.
Yes,
Okay,
exactly.
thank you. Thank you.
So this means that if you are, for instance, if you want to use the magnetic susceptibility and you have this data, you can insert here. But if, for instance, you are trying to get the magnetical susceptibility from other data. You will need to use the right software of geophysics to do that. So this means that you can use here, for instance, the cross sections from GPR. You can use here the electromagnetic already done. If you have the color selected, you will use just like in raster imagery in general. But we can talk about this further when we are with the software open too. So now let's just talk a little bit about the data outputs. So the same way we can insert a lot of data, we need also to get these outputs. So we can get these outputs from 3D surface and 3D volumes. We can get some output from structural data. And as you can see right here on the image, this is an output. Why? Because I had all this information of layers of dikes and veins and faults, and I need to insert it all together. And once I do that and insert and analyze everything, I can export and have a 3D model that is possible for us to understand how the campaign should go on. So we can also do little movies, the drill hole tables, plan our drill holes, the designs. So I have not mentioned, but the designs are very important if you are using another software. This is going to go a little bit more in the data inputs. So right here, the designs. We can also use in the data outputs, the designs too. But the designs, they are mainly for us to communicate with other volume kind of software, other 3D software. So if, for instance, if you still use Datamine or still use Serpec or still use GeoSoft, you can import everything from those softwares right here into designs. So this is going to be the place that you are going to catch all this information. So now just moving a little bit forward, who is Sequent? So Sequent is the global leader in development of visual data science software and collaborative technologies. And our industries are mainly mining, civil, environmental, and energy. Today, we will be totally focused on mining, and here it's a little bit about what I have already talked here with you about all the phases that we have in a project and how we can act on it with Leapfrog. So since the project generation, the target generation and test, the feasibility, the construction of the design and the pits, the mine operation, the reserves management, the waste management, and the mine closure. So we have all this workflow that is comprehended by the Leapfrog and also the solutions from Sequence. Here you can see Central as our cloud solution. We have MX Deposit, that is our data management solution, and Imago, which is our image data management solution. So there is an interoperability between them, and on Leapfrog, we can also tick the connection with IOGAS, DASWIC, USGS kind of data we can import on that. ILS, the core scan kind of data also, index from IOGAS. I don't know if you use that for geochemistry, but if it's necessary, we can link that on Leapfrog. And when we are talking about data management, we are talking about Central and MX deposits. So on MX deposit, you will be able to log everything direct on a cell phone, on a tablet, and this is going to be all in the cloud, and all of your administrators can see and already send that for QAQC or already send that for the next level of improvements. So this is basically the synthesis of the interoperability that we can find in the sequence solutions. So a little bit about our course outline now. We are going to, in this first and second day, navigate a little bit on the user interface, import our data and validate that, because this workflow that we are going to use, you are going to use in your data too. Why? Because this is always the same steps for the validation. So you're going to insert your data, you're going to validate that, import and validate, and you will see that the validation is basically done by two steps. So you import your data, and we are going to check if there is any problem on the processment. And if we have any problem on the processment, the software itself is going to warn us. And we will have two kind of warnings. So we are going to mention that. And after we get our data into the software, we need to start to grouping this interval and doing an interval selection. Why? Because we have already the data. Now we have to start analyzing it so we can start to model it. And after that we have grouped everything, we are going to start to do the geological modeling and the dynamic model updating, which that means that we are going to import also the informations that we have from different phases. As I have mentioned, we have the phase 1, phase 2, and also the phase of pits, when we are evaluating a little bit how the volumes are being constrained inside our pits. And on the day 3 and 4, we are going to focus a little bit more on the numerical modeling, drill hole planning, cross-sections manufacturing, image scenes, movies, and Leapfrog view, and also modeling from a map with no drilling data. So this last part right here, we can along the course. So today, by the end of the day, tomorrow, you can also tell me if you want to learn more from Edge in this final day, or if you prefer to try to do this workflow that we don't have any drilling data, that we have to do all the geological modeling with the structural data and with the historical data, because this depends a lot on what is your aim by the end of the training. And I know there is a lot of people that deal with a lot of historical data, and not just historical data from governments, but historical data from the company itself. So this is a little bit of our outline, a little bit of what we are going to do today and tomorrow and for into Thursday, and a little bit of the agenda of sorts. So this agenda right here is just to mention to us where is going to happen the breaks. So I intend to give a 10 minutes break in each hour that we have. And for just tell me if you need any extra timing, if there is a pray time or something that you need to get a break. There is no problem to insert that on the program. I will just try to keep that in the full hours so we don't get lost on the program. I'm sorry about the coughing. And now that we have already talked a little bit about what we are going to do, let's just speak by list, but not by last but not the least, about the additional training options that we have. So I'm going to show you a little bit after we do the Geo Fundamentals training, the course that you have available for free in the case of you that have the license, that is totally focused on Edge. So this is also a very good step for you, because by the end of those 4 days, you will be able to understand where you can get more material and where you can get assistance for your individual doubts. So also we have a custom training, and this is for the future. If you find that is a subject that you really need to nail it, your group is really need to upgrade the skilling on that, we can do a custom training and also a project assistance. The project assistance is if you have a project, and we can also do a training based on your data. So all of this you can also discuss with your CSM. And now that we have spoken a little bit of it, now start with our data and what we have for our course today. So at first I would like to ask, does everybody was able to download the file that I have shared? Please just tell me now because I can share it again and will be no problem do that.
Yeah, I think Sienna downloaded it and made it available to us all. The site you put it on was blocked.
Oh, it's blocked? Okay, yeah. So I'm just going to share again the link that is not blocked. So just a minute.
I mean, most people may have it, but I don't know. Hands up.
No problem. I'm just sharing on the chat again. So you have the link on the chat. If there is anybody that doesn't have the data, you can just check right now on the chat and you can already download that. Sorry, my Teams is a little bit stuck and I'm not being able to share the data. Just 1 second. Oh, now it's sharing. Perfect. So now we will have this little file right here. That is the gel found. And we are just going to unzip that. So extract it all. And we are going to use the unzipped file. So remember that we are going to use the unzipped file. And on this file, you will see 2 zipped other files. So we are going to start today by the Leapfrog Gel Fundamentals course data unzipped. So please let this file right here unzip it for you, because when we start to use that, you already have this separated on a file that you are aware of the path. So this is something that is important for us to be aware, because Leapfrog, you will not have problems with directories. The only problem that you may have is if in the starting of your project, you didn't have settled right the path where you want it, and then afterwards you can be crazy looking for your file and not finding it. This is just to make it easier for you to find your file afterwards. So if you click on the Leapfrog Gel Fundamentals course data, we will get the getting started right here and all the other informations that we are going to use on those 4 days. So now that we have already checked our data, so please, if anyone has a problem or any issue with the data, just tell me on the chat. There is no problem on that, because now we are going to open the Leapfrog. So I imagine that you have already downloaded the program and you just need to click on it, on the icon, and it will start to launch for you. So you can see on my screen right now that it's launching. Is the version 24.1.3. And you can see that there is something that automatically is going to be done. That is the connector opening in the browser. So the browser connector of Sequent, it's open right now. And I just want you to check, because the organization that we are in this moment is the International Resource Holding. Okay? So everybody had entered on this license right here. You just need now to tick the extension edge. So any problem, just tell me on the chat. Now that we have ticked the edge, we just need to click on Get Started. So after ticking the edge, after moving the organization to International Resources Holding, Get Started. If you want, you can just check if the group training is right, if the product is right, and you can check the subscription, the expiration of the subscription right here. So now let's just click on get started. So let's open it. And now we have our Leapfrog open. So you can see that my screen must be very different of yours because probably you will not have any recent projects or anything open on Central. As you can see, everything that I open, it gets here not open, but just telling that it was recently opened. So very helpful. And if you need right here to clear it all, you can. You must see your name right here. So if you check the right corner, you will see your name. You can check your profile and your permissions. So if, for instance, you have a little doubt if you have ticket or not the Edge extension, you can just manage your permissions and check right here. So by checking my permissions, managing permissions right here, I could see that the Edge is activated. So one thing that I wanted to mention here, I know that this sounds very easy, but if you are not being able to see the Edge extension and the features that you should have, please check right here because probably you may not have ticket the Edge extension on the browser connector. So now that we have just seen that, we can just check that we can switch user and also release seat. So if you're using a computer and you want to give this to your coworker and he wants to carry on the project on his sequence ID, just switch user. If you have finished your day and you want to make this seat available for other people in your workspace, just release your seat. And now I just want to speak a little bit about the other corner. We have seen here the right corner. Let's just now talk a little bit about the left corner. So on the left corner, we can do a new project. And this is just one of the ways that we can do a new project. So you can do a new project right here, or you can do a new project right here. So this is two ways of doing a new project that is going to end up in the same. And we can open a project that we have already in our disk. If we don't want to do that by clicking on the project, we can just search for it. We can see the About, Settings, Diagnosis, Help, Sequent Learning Center, Contact Us, and Leapfrog Forum. So let's pay attention on those four last. Why? On the Help, you will be able to see this interrogation points in several points of the software. And when you click on that, you will have a little explanation of what that means or what that feature is going to do. So this is very, very resourceful because every time that you see that is going to directly send you to the right page of it. So if we just click on that now, it's going to be the help page in general. But if we are looking into something very specific, it's going to be about that. So also the Sequent Learning Center. This is where you're going to find all the other courses. So I'm going to speak a little bit about surface editing, about construction of surfaces, a little bit of Edge, and you will be able to dive in on all those subjects after in the Learning Center. And of course, I'm going to pass for you all the material attached to it. And also the Contact Us. Contact Us is for the support. So anytime that you have a doubt or something that you're stuck at, the support has until 24 hours to answer you. So any problem, just click on that, contact us, and you will go directly for the contact support. And you will be able here just to input your doubts and your region, what you're working, the product that you're working, and you will be able to be responded very quickly. And also the Leapfrog forum. The Leapfrog forum is something that I also mentioned because it when we are doing a project, it's very common that we get stuck in some few subjects that it may not be that difficult to pass by, but we may need somebody help from the community. So when we check on forums, maybe the most uh, common kind of errors are going to all be found there. So it's a perfect place if you are trying to get more confidence with your software usage to see how people are dealing with the same problem as you. And of course, when we are talking about real data on the real world, we can find a lot of different kind of problems, and those problems generally are related to other projects too. So you can check here on the community how people are dealing with the same kind of problem. So now that we have checked it here, I have shown you two ways of doing a new project. So we can do a new project right here, or we can do a new project right here. But I also had shown a third option of you just getting a project that is being done. And we are going to do that because Leapfrog is always releasing a new update. What that means? That means that yearly we release a huge update, and also we release through the year the updates for the bugs and little advances that we are intending to do. So, for instance, if we have a lot of contacts on support that the geologists are in need of some specific feature, this specific feature is going to be developed and then relaunched on the next updating of the software. And what happens to all the projects done previously? And this is what we are going to see now, because this project was done in an older version of Leapfrog, and we are going to open it. This way, you will see what happens when we are trying to open older data on Leapfrog. So you need to go on your Leapfrog GeoFundamentals course data that we have just unzipped. And now we just need on the getting started, we will see the Oliver project that must be unzipped too. So just repeating the Leapfrog GeoFundamentals data course, the getting started Oliver project. So click on the Oliver project and click on the Oliver project with the little icon of Leapfrog. So if you double click on it, it will launch Leapfrog. It will open with Leapfrog. So if anybody has any problem in this part right now, just tell me. So we just need to wait a little bit to the program open it. And now is the message that we need to check and we need to make a decision. Why? Because this project needs to be backed up and upgraded. What that means? That means that the software itself is able to understand when a project is older and how old is this. So this project right here is from 2021. And you can see that the program was able to get all the new versions, updatings, and also showing what is going to be changed in the project if we upload that to update that to the new version. So that means that we are going to move forward. And what that means that we have here three options: processed backup, unprocessed backup, and create a copy of changed objects. So the processed backup is going to be the most viable one. Why? Because on the process backup, you will not have any problems. You will save a processed backup of this project. And if you have a lot of things attached to it, it's going to be a way that is not going to take longer when you open your computer. But it will take more memory from you, but it's going to open faster and will not have problems of processment. Unprocessed backup. If you have problems of memory, this is the ideal one. It's going to take longer when you open it because it's going to process your data again. So in our case right here, this project is just, it is empty. So it's just for you to understand how this works because using Leapfrog, you are going to face this. It's pretty common. So a new version is going to be released probably in October or November. So on this new version, you will already have to do that with the older versions of the project. And you can see that this is pretty easy. I was just explaining the difference of the backups, and I will do just the processed backup here just to show you how it works. Because my processed backup now needs to be saved somewhere. So I am just going to save it right here. You can save in the place that you find better. And now we are just loading this project. And you can see right here that, sorry. So this is the complete project. And you can see right here that we are just finishing to process the final parts of it. So this is going just to show us a little bit of our layout right here. And we can check a little bit of what we are going to see and do on the feature. So sorry, I thought that I had shared just the project that is empty, but this way is way much better because here you can see all the project and what you need to do on it. So I just want to check with you. Have you been able to open the project? If there is somebody here that wasn't able to open the project and it's not processing, sorry, Babita, you were not able.
It's crashed.
Do you want to write it on the chat? Sorry, I think it's a kind of an echo in the sound.
Crashing, Julia. Crashing.
Sorry?
It's crashing. I'm trying to open it again.
Uh-huh. Oh, no problem. This can happen. So the crashing is actually because of the hardware. So if your C disk it's a little bit too overwhelmed, it will have a problem to do that. So can you just take some things out from the C disk? So this way you will have more internal space. So I just want to mention this part right here of the processing, why was still going on, but there is no problem because we have this right here to show that we have some tasks to be completed. What are those tasks? Those tasks are basically everything that was updated from 2021 into 2024. And this is the way of Leapfrog to process that. So we already have our backup, and now we have our new project right here updated. So what I wanted for you to open this project with me too, this project that is complete, because now we can start doing the visualization already with some data. And then I'm going to enter a little bit more on how we are going to input the data doing a new project. So at first, let me just get it clear. Everyone here was able to open the project. Arushi and Babita, are you still with the problem to open it?
Yeah, Julia, I'm trying. I'm trying. You can continue. I'm trying here.
Okay, but don't worry because we are not going to use this project. So this project here is going to be for our visualization and for you to understand what we are going to perform. So, sorry, we have it right here. As you can see, the three axes. So we have the y-axis, the x-axis, and the z-axis. Also here, we have the scale of it and the plunge and azimuth that is being represented right here. The first thing to mention, Leapfrog doesn't have unities. So what that means? That means that you can input here any kind of coordinate system, but you must be aware if all the data is in the same coordinate system, because if it's not, we may have a problem of things not being right placed. So things will be a little bit displaced, and the problem will be the coordinates. And since the program is unitless, we will not be aware what is happening. We will just see the displacement. So if you have this problem, just check on QGIS or any kind of open software that you can check if the coordinates are in the same pattern. So here it's one thing that I wanted to mention too. It's about the layout. Why? Because we can change this layout if we want. So if you prefer to work in another way to separate those, to detach right here, to separate the windows, you can. So let's now just talk a little bit about the settings, because right here is where we can change the colors. So if we click on the settings right here, we will see that we have our color scheme. And if we want, we can input the default, black background, white background, or we can do our own. You can do the kind of background that you prefer. So you prefer, if you prefer a red or a blue background, there is no problem. You can take control of that. I prefer the black one because it makes your vision less tired. So the lighting, you can also control the lighting of your project right here. So I'm just going to input here a project, our model. So you could see that I just needed to drag and drop our model, but I just want to insert this right here so you can understand what is the light. So if I input the light 3 and I insert that, you could see the difference. So if you're having any kind of problem of visualization on your project and you are not enjoying the colors or the way that you are visualizing that, you just need to come right here, settings, and just take a look on the lighting, the shadows, and the colors. And probably you will find the best fitting for you. And right here, if we check, we can see the processing. This is about the background process, and we can input how much we want, but I'm just going to leave always in default. So the user interface, so this right here is for us to see our tree. So you can see right here, show tree lines. What that means? That means that little line that you are seeing here, that are connecting the files. So if I take this out, you can see that I don't have this connection anymore. I think it's for fresh starters, the best is always to have these three lines. So please, Michael, tell me. Hello, hello.
Yeah, just turning the mic off. I missed how you got the settings. I mean, I can see all the left tree, but where's the settings?
Uh, the settings here,
Yeah.
sorry, you lost?
Yeah. I mean, you click so quickly, I couldn't see where you went to get that window up that says settings.
Ah, okay, sorry. So just let me fit better because I think my screen is too, maybe it's not showing the whole software for you. Maybe this is going to be better. So right here on the right corner, on the left corner, besides Leapfrog Geo, we are going to get settings. It's going to be right below about. So just clicking on that, we are going to open this window right here. So on this window, we will be able to see the overlays, the color scheme, and the lighting that I was mentioning. That is going to make a lot of difference in the visualization, but I would suggest that you only change that if it's some way bothering you or you're not being able to visualize properly. So change that if you want it, and also the processing, the using interface, that it's basically talking about the project tree and how you're going to see that, and also the projects where they are going to be saved. So do you remember that when you are trying to open this project, you have the option processed or unprocessed file, and this is going to be saved somewhere. This is the place that you can input to be saved. So if you want, you can just change your default location for the project, and you also have a place for the central project. So the projects that you share on the cloud. So right here is the default request timeout and also the usage policy network and the coordinate system. So what it's going to mean, this coordinate system, if I had just tell you that the Leapfrog is a unit class program. This is going to fit for you to have this specification for all your crew. So this is a place where you're specifying what is the coordinates and what is the unity that you are using. For this way, everybody on your team and every time that you are going further on your part on your project, everything that the program will show you is going to be on meter. So this is the way for you to do that and to get some warning options if we have some potential coordinate mistakes during the publish or importing of something. But this right here, for me, since I have unspecified, my coordinate system is just going to be based on the units. So for instance, if I'm trying to import something that it's not on meters, it's on feet, the program will tell me that this is on feet, it's not on meters, and it's going to be a little warning there. So now that we have checked a little bit the settings, now let's just close it and give our little interval. So we are going to be back at 12 and 30. This is a great moment for doubts. If you have any doubts, if you're stuck anywhere, please tell me. Uh, Tiana, if you want to see this error, I must be honest that I think that this is an error attached to the C file when it's too full. Is not able to back up what you are trying to back up.
No, my C
Uh,
drive is not full. It's half
no.
free. It's half free, so
Oh,
it's not that problem.
yeah. Okay, okay. So does anybody here had this problem also?
Julia, the same issue is with Babita also. Is it because it is like if we have saved the project or the files in OneDrive, that is why?
Yes, yes, for sure. Thank you very much, Arusha. You have finding out the problem. So you need to save it on your driver. Leapfrog is not very compatible to OneDrive, And this is actually for all the kind of GYS too. You can save the files separately, but when you are trying to save a project, you may have problems on that. So it can work. Sometimes it works, but it's not going to work every time. So
Yeah.
if
Okay. Yes, yes, you can continue.
yeah, so it's going to be basically that. Um, please try to save on your driver. Gianna, you have already done that, right? You are already trying to save on your driver.
I try to save it on my C drive. I'm now
Yeah, yeah.
I'm now trying in another location. Let me see.
Okay, try on our desktop or something like this. But as I had mentioned, we are not going to use this project anymore. It's just to show you the general features of Leapfrog with something. But we are going to start a new project since you are all having the same problem because it's going to be easier this way. It's going to be exactly the workflow that you are going to follow alone afterwards. So I am just going to give the tiny break for I believe that some of you want to fresh up a little bit and just walk home a little bit. So on midday and 30, we are back. Okay?
Okay.
Please tell me if you need more time or anything.
No, that is fine.
Okay. So I will be back in a few minutes.
Okay. Thanks.
Hello, hello everyone. So we are back. Just resharing here my screen with you. Please tell me if you need a little bit more time.
Uh, time चाहिए किसी को? No, Julia, that's fine. We can start.
Perfect. So you have seen that I was on the tab Scene View, and now I'm going to the tab Projects. So if you were not able to open this project, it doesn't have a problem. That's okay. We are just going to create a new project in our tab projects. So one thing that I just wanted to mention before that, you have seen that we have a lot of files here. And if I want to see my project tree a little bit cleaner, what should I do? Right click on the top and you're going to say collapse all the rows. This is going to be the same process if you want to detach the project tree and have this in another place of your software. And if you want to hide the project tree either. But here we are just collapsing. Why? Because collapsing, we can understand a little bit better what we are trying to reach. So if, for instance, this was the first time that I was opening this project, I would collapse it and just go for the geological models to check what we have here. So in this project right here, we have the geological model and we have a weathering model. So if I want, for instance, just to know what is happening to the points, or if I wanted to know what is happening to the topography, I could just go directly here. So this is going to get way easier when you are using Leapfrog. Is going to make all of the sense. And if you want to clear your scene, we are just going to right here on the top, we are going to clear the scene. And another thing that I wanted to mention right here about visualization of the 3D axis. This can be a little bit harsh on the fresh starts, but after a while, you just need to get used to the buttons of the mouse. Because what is going to happen? We are going to click on the left button and we will have this fix to be rotated. If we click on the middle button of the mouse, we can get it all together. If we scroll in and out, we will have the zoom in and out. And also, if we go with the right click, we will have the zoom in and out. So right click, in and out. So now that we have already checked the basics of it, let's just open the new project. So right here on your projects, you are just going to do a new one. And you are going to name it Oliver Day 1. Just a tip, but I think that you as data managers, you already know that, but to input the date of the things that you are doing always, because this is a perfect way for you to find out your files afterwards. You just need to check on your agenda what you were doing on that day. Oh, that was the day that I was working on the model. So you can just go write the date and you will find your file. So it's just a small tip for data management right here. So you have inserted your name, you have inserted the folder that you want this, and if you were connected to Central, you could also upload this on the cloud. But as we are not, let's just do the OK. So we have here created the Oliver project. Oh, this is the old one, sorry. So I'm just going to close here my Leapfrog and open it again. And now I'm just going to create a new project and it's going to be our little project, the Oliver one. So Oliver, day 1. And we just need, now I'm just going to insert that in a closed place. And we are done. So everyone here were able to open the new project. So on the project right here, we have those two options. We can do a new project or we can do a new project right here. So you just need to choose one of those and then to open the project. So please just tell me if some of you have any problem to open the project right now, because now we are just going to start to import our data on it. So we have here our project tree. Our project tree is going to dictate a little bit what are the data that we can input, what should we input first, what we should care less. And right here, we can see what is really important for us here is the topography. The topography is really important. And why? Because we are talking about a 3D software. So it has to have a surface so we can start to understand what is the underground and what is the surface. So right here, the topography, it's very important. And if you right click on it, you can see new topography and all the options that we have. So the new topography can be a new elevation grid. It can be a fixed elevation. So what that means? That means that if you don't have any data of topography, you could just do a fixed elevation. So you can set an elevation and just do a surface. This is because the developers of the software can understand that it's very important for us to know where is the surface. So where is the 0 point of getting the underground or the surface. We can get from a surface that is a mesh, or we can get this from a GIS vector data, and also from points. So we just need now to check a little bit our data. So if you go back to the project, if you go back to the file where you have the project, Leapfrog GeoFundamentals course data, we can just take a look right here on the importing drill hole data and topography and surface data. We can check how our data is. So if we go to the topography and surface data, we can see that our topography is in points. And we have some shape data and also some aerial photo data. And if we are importing our drill hole, we can go to the original import, OL drilling, and just take a look how our data is separated. This is an important part, right? Because we are going to import drill data always in the same format. So we need the color, we need the geology or any kind of intervals that it's important for you. It doesn't need to be the geology or the lithology if this is not what you are using. If you are using any other category, it can be colors, it can be a soil type, or any kind of category that is important for you. And the survey, what the survey is. On the survey, we will have the dip and the strike of our data. And this is very important when we are talking about drill hole data because we need those informations of orientation. So I just want to show you how this data is organized because this workflow here, it's very important for us to understand clearly how it's done because once we get it, it's pretty simple. So we have the essay, we have the color, we have the geology, and the survey. We are just going to open right here so you can check how this is. So this is an SVS file, and we have right here on the color the information that I need. That is the hole ID, X and Y. So, and the from and to. So right here we have the intervals. Right here we have also the elements that we are going to analyze. So I have separated here a project for you that it's involving copper and gold, because generally when we are talking about modeling, polymetallics are the more classical ones. But that doesn't mean that we are just going to take a look on that, because to make the surface, we will have to make several types of surface. So now that we have already our software open, we can start to import our data. So we are going to start by our topography. If you come right here on our project tree, you will see the points. If you right-click the points, you can go to Import Points. And you are going to have three options for importing points: local, from Sequent Evo, or from a database ODBC. So in our case right here, it's local. And in our case right here, sorry, I just need to connect with our rights file. Oh, sorry, just a second. So we just need to connect that with the right file. So right here, points, import points, local. In my case, I know that it's on my desktop, so I just need to go there and go for the geofont, the Leapfrog, and the topography surface data. So I'm just letting here for you to see the path is the tree topography and surface data. We just need to click on that. Oliver Topo Points. We are going to click on that and open. One thing that I wanted to mention here, the types of files that are accepted as points. So it could be a CSV, an ESC, an ARA, an DXF, and .dat. So we have several options right here to import our points. And now that we have just selected, let's just do the open right here. So we are opening, and this is the validation window. So the validation window, we are going to see exactly this way as a validation that is going to open for us, and the things that we may have problems here that we need to check. This data right here was done to make it right. So the topographic points, we would not find any error. But if, for instance, this was our raw data, we could find some problems. What kind of problems we can find? First, the delimitators. So if you are inputting that as a CSV file, you can have problems with the characters. So you just need to come right here and change the character. So for instance, if I change to point, you can see that the program cannot understand what is happening anymore. So I have to come back to the comma. Oh, sorry. To the comma, and now the program can understand anything. The same thing would happen if it was the opposite. Sometimes you just need to change the delimiter character right here because it's not the same as you are using on a CSV file. Right here, this is all validated. If you want to check out what are the options of categories that you could import those headers, you have right here. But every time that we are importing something to Leapfrog, it opens a kind of wizard. And this wizard already knows what is the most important data for us as geoscientists. So it has already settled the X as east X, the Y as north Y, and Z as elevation. So right here, we just need to finish. And we have here Oliver Topo points, but with this little sign of error. And now we are going to see what happens when we have an error. So right here is the workflow of inserting data. First of it, check your data. your result will only be good as your data. So at first, always check your data. Is on CSV. It has a clear header of what I am trying to reach. It has clear categories. It has all the informations that I need or have more informations that I need. Because if we insert a lot of informations, it will get hard for us to understand the analysis. So it's important for us to keep the light as possible. So just inserting what is important for us. So now that we have the Oliver topo points with an error, what we should do? We should right click on it and click fix errors. So when we go to fix errors, we are going to find duplicate points. So we are just going to expand that. So errors, expand that and click. And you can check right here above, ignore duplicated rows. And we are just going to click on that. After clicking on that, we are just going to save. And now we don't have any kind of trouble in our Oliver topo points. Things to be aware right here. I have right-clicked and you could see that along with fixed errors, I could export my errors. And why? Because Leapfrog cannot change your database. So if you are changing right here, the program, of course, it's awesome because it shows you all the errors that you are having and what is the classification of this error. If it's a maximum depth error, if it's an ignoring cell error, if it's a duplicate point error, it will show you what kind of error this is. And you will be able to also fix it on Leapfrog. But this is not going to be fixed on your database. So very important to be aware. If you want to fix that on your database, first of it, export your errors. After you export your errors, you will fix it. And after fixing it, then you will export it. Why? Because this way you will get the file that it's wrong and the file that it's right. So what you have done here, you have make your database correct for all of those that will use that afterwards. And it can be on Leapfrog or it can be in any other kind of software, but this data now will be fixed, which is great. And here we have seen a little bit of this error, but we will keep seeing this error here because this is the fundamental practice for us to start using Leapfrog is how we can handle all the errors that we are going to find in our raw data so we can start our interpretation and then can start to see and visualize our deposit, our model, our geology, our underground in general. So now that we have the Oliver topo points right, we don't have that warning anymore, and we can just get this to the topography. If you remember, when I had right-clicked on new topography, I could import from points, and that's what I'm going to do right now. So there is any doubt in this point? There is everybody was able to open a new project to insert the topo points and now to do this next step of inserting the topography.
No,
No.
I've got still 10 duplicate points. So how do I get rid of them?
Which part are you? Sorry.
I've got errors with the 10 duplicate points.
Oh, okay. So you were right here, fix errors. You have right here duplicated points, right?
Yeah.
So right here, ignore duplicated rows. Just click on that and then save it.
Okay. Yeah. Thank you.
It had worked?
Yeah.
Perfect. So now that you have done this part, we are just going to insert that on the new topography, and this is going to be gathered from the points. So topography, right click, new topography from points, and the Oliver topo points that we had just inserted. So if you want to change the name of it, you can. One thing that it's very important to be clear here, you can only use one surface to be the topography. So if we are using the points as the main topography surface, this is going to be the one. So we can change it, of course, but we can just use one by time. So if you have two meshes, you need to merge that and then you can insert on the topography. Oh, sorry, sorry. There was somebody was speaking or not? So
No.
you just okay. So just inputting the okay right here, and we have the topography. So if you have any problem, if your hardware take a little bit longer, there is no problem. It will appear right here on the processing. And you can see that on the processing, we also have the runoff, priority, and pause. So if you are having any problem with processing, always check here, because if it's too heavy, your computer can pause it. So just check if it's not paused, because this can happen. You can be waiting a long time for processing and then just check there that it's paused. So just keep aware of that. It's going just to appear here a pause. The two straight lines here is going to appear if it's paused, but just be aware of that. So now that you have the topography, you can expand it and it's going to show what is based this topography. So as I was saying, we cannot now insert another surface or things like that, but we can add high data. What that means? That means that I'm using my points. But if, for instance, I have a LiDAR or any kind of topographical campaign that is making more accurate my field information, I can import here as adding hay data. This is also going to be useful when we have the colors and the colors are not matching exactly the topography. We can adjust the topography to the colors, or we can adjust the colors to the topography. So this depends on how reliable is your data, and you have to have this knowledge of which is the more reliable data. The color of the drill holes, the topography, maybe a third campaign. This is depending on your data, but it's possible to do both ways. So now that we have already inserted our topography, we can just take a look on it, just drag and dropping on the screen. So we can see right here that our color yellow, it's the top, the color green, gray, sorry, is the bottom. And we can see right here that our resolution doesn't seem to be the best one, because we are almost seeing something that is horizontal. So we can just check our resolution. So now we are going to double click on the topography. So when we double click on the topography, what happens? So here, let's pay attention on 3 points. The first of them, boundary box. You are seeing here the boundary box of the topography. Everything that we are constructing on Leapfrog is going to be limited by a boundary box. You are seeing here the boundary box of the topography. We can use the same boundary box for several other kind of elements that we are trying to trace. But as you can see, the Z elevation of our topographic boundary box is not good enough for us. So we probably are going to just leave this boundary box for the topography. So we could enclose an object if we want, and also the resolution. So the 3 points are boundary box, resolution, and trend. So the boundary box, we have checked it right now. We don't have any more data at this point, but if we want to change this boundary box, we could just going down or open or just less wider. We could insert whatever position it's comfortable for us because we don't have more data. So we could enclose also this topographic extents. If we had more data here, we could see that more options will be available for us. So right here, we can see that the topographic extents, the boundary box, is just going to be around the topographic points. So now that we have already done that, we can see the surface resolution is too big. So we are just going to input 30. So we are just going to use a single pass ISO surface. We are not enclosing the object. And what was the third point of importance? The trend. So the trend, what it's going to be? If we have, for instance, any information that we had a trend here, we had a plane, we have a shear zone, we have something structural that is telling us that we have a trend, we could set a trend from a plane. And how we could draw this plane? So we could set from a plane right here, and this plane would be already done. We can set to a topographic or isotropic, and we can also here view the plane. So you are seeing the plane right here. If you want to check just the plane, we can go right here and take off this little vision from the topography. So we have the topography on scene, but we are not visualizing it. We are just checking it. And right here is the plane that we have already seen now to set our topography if we want to. We don't want this right now. I'm just showing the options that we have here because these are the 3 points most important for us to take a look on the general and the trends of the topography. So I'm just going to cancel this right here because I'm going to double click and just change our surface resolution to 30. So now that I have my surface resolution to 30, I'm just clicking on the OK. So now with the surface resolution on 30, we could see that we can get way more characteristics from this surface right here, this topographical surface. And now let's just talk a little bit about this visualization. You can get a little bit crazy if you just go with your mouse on the beginning, because you're probably not very used to that. So you can use another tool that it's right here on top. You can look and you can look east. And also you can call this with your keyboard. So if you're just putting E, it's going to work in the same way. So you can put west, you can put south, you can put north, up, and down. I will say to you, the one that we are going to use the most is going to be the east and the down. And you are going to understand why, because when we are trying to edit and when we are trying to cut, we want to see a perpendicular kind of view and a side view. So this is a perfect way for you to visualize the place that you want, for instance, to do a cross section or a slice. So now let's just talk a little bit about the options that we have right here to do the slicing and to do the plane and also the ruler for us to understand the distance on our project too. So we have right here, if we click on the slicing, we can just do a new slice of our project. You can see right here that we just have one surface. So this is not very meaningful for us in this moment, but it's important for us to understand what is happening. So we have here the slicing, and we can also edit features slicing it. It's very important to know that because we are going to edit some features, and also on your project's daily basis, you will also edit some features. And this is going to be way easier if we do on the slicing mode, because we are going to see just the slice that is important for us. So if you want to change your slice manually, you can. You will have this right here for you. So let's check the options that you have. We are going to have the option to create a set. So a set is going to be several other slides also happening here. And by creating this set, we can input the number of slices, the dip, and the azimuth of it. We can check a really preview right here on the screen. This is going to be very useful for us on the third and fourth day because we are going to export and do our sections. So this is a mainly way that we are going to use to do several in a once. So now that we have just checked the slicer, we can see right here that we can change the dip azimuth. So for instance, if I want to have a 90-degree here, and also the dip azimuth. Here on the slicing, we can change. So if I input right here this way, I think you will be able to understand that. But now we have a feature that can take a little bit from this side and a little bit from the other side, doing almost like a buffering with your slicer. So when you have the slicer, you also have several options of visualization, and you can see this right here. So if you check on my mouse, you can see on the slicer, we have the option to see the thick slice. We have the option to see the remove the front of the slice, the remove the back, the remove the alignment with the camera. We can also, sorry. We can also slice just the east or just the bottom part of it. So now that we had just checked the slice, we can just take it out. The slicing, we can do one here and we can call it here. So you do it here and you call it right here in the same place. So right here, I'm just going to click on D. So this way I can see my screen. So after clicking on the D, I am just getting my ruler right here to show you how the ruler works. So we are going to have the ruler right here and the distance show it right here. This distance right here is in meters. So just for you to be aware and why this is happening on meters, because as you can see right here, my notation of everything that we had inserted on the project, it's on meters. So that's why I know that it's already on meters, but please be aware of it because if you're using different unities, this can be a tricky number. So now that we have already checked a little bit of the topography and the things that we could do here, we are just going to check the GIS objects that we can drape it on it. So if you check a little bit on our file that was right here, we can see that we also have some surface data. And those surface data is also some polylines that we have in shape and also some aerial photo on a TIFF file. So we are going to insert all of this in our topography. And I have just cleaned here. So if you want to click on the X, you can clean. But if you want to clean everything at once, you can clear the scene right here on the top. And now we are just going to go for GIS data, maps, and photos. And we will start by a new GIS line. So this new GIS, we will start by importing the map. So when we click on importing the map, it's going to open the file, the window for us to find out the image that we want to insert on it. So you just need to go on the Leapfrog GeoFundamentals course data, the topic 3, and to click on the Oliver aerial photo. So if you click on it, now let's just open. Please tell me if anybody has any problems on this step right here, because we are importing the map, and now we can check the aerial photo. So now that we have checked the aerial photo, what is the problem that we have here? This aerial photo is not draped. So it doesn't have any kind of surface information. So how can we see the topography and see our aerial photo too? We need to drap it. So for us to drap it, we just need to go right here on the Oliver aerial photo or anything that is on the GIS data maps and photos and right click on it. When we right click on it, we will have an option that is going to be to drape on the topography. Once we do that, you have checked that we now have here an Oliver aerial photo on the topography. So we can just put that on the scene and check it on the topography. So one thing that I wanted to mention too, I'm just clearing and bringing just my topography here. You can see right here that I have attached this to my topography and I can take it out. So for instance, I just want to input none. I could. So I can just go here, maps and photos, and put again our map because I wanted to see that. And you can ask me, if I didn't have this photo with a georeference, could I do a georeference in Leapfrog? Yes, you can. You will use 3 points for that. So you will just need those 3 points of reference to do dojo referencing. So if you have this possibility, or if you want to do that, you can. You can just import the map and do the georeference on that. We can see more that on the fourth day if we choose to build the map from historical data. So now that we have inserted our map right here, you could see that we could also insert our GIS data as as lines right here too. But at first, I just want to be sure that everybody's following up. We don't have any troubles until now. You were all able to drag the photo right here. And now I just want to show you a little bit of the elevation, the face dip, and the dip azimuth. And why am I showing you that? Because I was mentioning a little bit that we could do geotechnical domains here on Leapfrog. And we can. We could already do a separation here of domains through the azimuth and face dip, or just the elevation if you prefer. So we could just insert right here, show legend in the scene. So this is the elevation, and we can see the legend right here. And we could just go down on the color map and click on New Color Map. When we click on a new color map, we will have two options. The continuous, that is, this is a continuous gradient, or discrete. And what the discrete means? The discrete means that we are going to make categories. So if you click on discrete, you will see all the data separated. So we could see right here on the edit color map, we could see the histogram of this data and also how we could separate this data into different categories. So, any doubts here? Sorry, I had heard a little noise. I don't think so. So just carrying on, we can separate it as categories, as intervals. So right here, we can just input an option to see the histogram of the log. We can see the cumulative histogram, or we can see we can change the bin wild. What is the bin wild? Is this wild right here. So each column is having a bin wild of 3 right here. 3 what? 3 meters, because we are talking about meters, we are talking about elevation. So I'm just going to generate some intervals right here so we can understand how we can generate intervals so easily, because this way we are using right here for topographic, and this could be for geotechnical domain, but this could be any kind of other data. Sorry. So we could have here numbers, and I could be done that with the numbers. So the essays numbers, I could be already separating right here. So we are talking about a really initial stage of the project that we already can get a lot of information from it, because we can get the categories. So right here, we can just put the generate intervals. And when we click on that, it's going to tell us the data, where this data from, the interval mode that we can separate a quantile, a progressive double, equal intervals, logarithmic intervals, and key-means clustering. So you have all those options right here to change your categories. And right here, you can see that my data is from, it has almost 100 meters of distance between the lowest point and the highest point. So what I could do, I can change also the colors if I want, and I could just apply it. So when I apply it, I could see it right here. So what this data is meaning, that inferior to 703, we have blue. In the middle, we have this greenish, and the higher parts, we have the red one. This could be set for the dip too. So we had information of dip. We could set for the angles of dip. We could set this just for an elevation that it's high. We could have done several types of categories here. What is important at this moment is that you understand that it's possible to already do categories with your raw data. So right after you have corrected your errors, you can already individualize your data from what is important for you. So now that we have done this little tryout, we can already jumping a little bit to our drill hole data. So we have checked how to insert the topography, how to insert these objects and to drape it. And now let's just jump in to our drill hole data. And why am I saying that? Because if you follow right here, your project tree, you can see that your next phase right here will be to insert something of sampling or some information that you have. So this could be also the designs. We could also insert polylines or points if we had, and the geophysical data right here, if I right click on it, I could import 2D points. I could import 2D grids. I could import 3D grids, and also some cross sections. So right here, if we check and open, you can see all the formats that are supported for the geophysical data that you insert on the program. So this is all the supported formats, and we can see that the main ones are all supported. So now just coming back to our data a little bit, we can just go to our little file to check again our drill hole data. So this time we are just going to do the original import right here, and we are just coming back to our project tree, collapse all rows, cleaning everything, and on our drill hole data, you're going to right click on it and import drill holes from local. And you can see right here, when we right click and say to import the drill holes, we will have the information that I have already warned about on the data preparation, the informations of color, survey, intervals, and points. So as right here, we are just going to call for the color. So we just need to go back to the original import, OL drilling, and we are just going to start by OL color phase 1. We are clicking on that and clicking open. So if anybody has any trouble here, just tell me. We are just going to click open. And what you could see, that once I click open, the wizard is already working and it brings me what is interesting for me. So I have my geology and my essays already inserted on intervals. That is what I wanted. The survey is already here and the color is already here too. So one thing that is important for us to be aware this way is that if we insert the name survey, color, geology, lithology, category, number, essays, we will be able to use the wizard, and the wizard will be used pretty easily. The wizard that I'm saying, it's the plugin on Leapfrog that is called the setup wizard. So when we are importing something like the topography, the wizard was already able to understand that the X, Y, and Z were the ones from the coordinates. So you need to always check if it's proper, if it's right, but in general, it's right. And it gets a lot of time compensation for that. It's perfect. So you just need to import now, and we will start to see things in a similar way that we were seeing to import the data from topography. So we have here our little window, right? And now that we have our little window, we can take a look if everything is making sense. So right here, the face, you can take a look in two ways to change the header. We can take a look here, expanding, or we can take a look here, expanding. So if you want to import this as a category or a timestamp or something like this, we could already input that. So we could put that as a timestamp or as a category. And right here, we are just going to input as a category so we can take a look on this. But right here, we have some dates. So when we are talking about dates, we have here the option dates, which makes way more easier for us because once you input as dates, you can also change the format right here. So if you are using other kind of formats of month, day, and year, we can change right here. So you can change to the notation that it's the one that you are using. So in our case right here, this is the one that is fitting. So we have the month, the day, and the year. The same thing with the CSV characters. So if you're having any trouble right here, you can go by the delimiter character and take a look if this is not the problem that you are having. So now let's go to the next one. We have here now the informations of survey. I'm just going to collapse everything here so we can take a look if it's right. So we have the azimuth, we have the dip, we have the depth, and we have the whole ID. So we have it right. Let's just go to the next one. So right here, we have our essay. In our essay, we have numerical data. So we are going to insert it. I'm going to do right here. You can do right here if you want, but your gold that is coming from your laboratory, this is going to be numerical data, right? And the copper will also be numerical data. So now just doing the next, we are just now going to input here our important information from our data, that is the information from lithology and information from our geology right here. So we have the stratigraphy and we have the simple lithology right here. So once we are inputting the geology, the stratigraphic should be the lithology. And the simple lithology is also going to be as lithology. And we are going to check here that we have some very, very simple differences on it, but we are going to compare both to see where we are going to get our information from. So after we get this geology, stratigraphic as lithology, we can just finish. One thing that I wanted to mention is if you have a trench data or things like that, you will also be able to select that afterwards. So now we just go for finish, and our drill hole data is being processed. So we can check right here the processing happening. And for me, it's already done. I don't know if your processing have already finished too. And we have several errors right here. And those errors are the things that we are going to hand on the next, after this small interval. So please tell me if you have any trouble to be right here with me, or if you have any doubts or any problem until this moment. We are going to come back on 30 in 10 minutes. So it's going to be we are in a different time zone, so it's in 10 minutes. Please tell me if you have any kind of trouble, if you were not able to get to the same place as me right here, if you didn't have your topography, if you were not able to draft your GIS object, because now we are going to talk about the errors and we will fix each of those errors right here, so we can already start to group and select the intervals for our project right here. So please tell me if you are having any kind of trouble. We are coming back in 10 minutes. Okay?
Yeah, my aerial photo didn't sit on the topography.
Sorry?
My aerial photo didn't sit on top of the topography. It wasn't draped on the top.
Oh, okay. So you just need to right click on it
Right
and
click
tick
on, yeah. I did
on
that.
topography. And it's not appearing here.
Yeah, it says view object and on topography are both clicked.
Can you share your screen so I can understand what is happening?
Yeah, yeah. Let me see. Do you
Okay,
see?
I can see it's right on top of you. So
Yeah,
you are
it's at a set elevation. It's not draped.
it's rapid. Yes, it's right on top. So I already understood the problem here. I'm just going to share my screen again, and you just follow me, okay?
Yeah.
So first of all, collapse all your rows, because you are seeing here the Oliver aerial photo, but you need to see here. And you are, I could see on your project right here, Oliver aerial photo on topography. So
Just
clean
remind me again
all
how to
your,
collapse.
oh, sorry. Right click here, collapse all the rows.
Okay.
So collapse all the rows. And now right here, let's clean the scene. Clear everything. So clear the scene right here.
Yeah.
You have it cleared and collapsed, right? Now on topography, right here, just expand this. Right here, drop this object, expand this. This right here, Oliver aerial photo on topography.
Yeah.
Take and drop. Are you seeing it?
Yeah, so. Mhm.
Perfect.
Yeah. No, good.
Awesome.
Thank you.
You're welcome. So we are getting back in 5 minutes now. So 6, a little bit more. But we are going back. If we'll have any doubts, just tell me. So I'll be back in a few minutes. Hello, hello, everyone. So we are back. Now let's get in on with our drill hole data. Please tell me if you need a little bit more time. Please tell me if you have any doubts, because now we are going to get in a part where we need to understand the errors that we are seeing, and also a part that it's fundamental for us to be able to build our geological projects. So if you check out, we have basically a workflow that is for our data insertion. So these workflows, it starts with preparing the data. So selecting the drill tables that we have just done. So the color, survey, intervals, and also we have right here the information that I have spoken with you that were the important ones. So the whole ID, the X, Y, and Z data on the color, and the maximum depth of the drill hole. So on the survey, you need to have the identifier, the deep azimuth, and the depth. And on the interval, the whole ID from 2 and the category, numerical numbers, lithology, text, URL, or whatever it's important for you. So after it, we are going to import and visualize the scene to check the errors. And afterwards, we will see if our data contains errors or warnings. We already know that we have errors. So one thing that I want to mention to be clear is that when we have a warning, things needs to be checked, but it doesn't mean that you have a processment problem. When you have errors, you have for sure an error that will influence your processing. It can stopping your processing to occur or can make it you have some results that does not make sense. So after seeing those errors, we will be able to check if we want to export those errors first or fix those errors first. This depends on your data and if you have a database where you want to fix everything. Because if you want to fix everything, you are going to right click on your drill holes on the individual table. You are going to select export errors. It's going to create a CSV errors to fix the source database, and afterwards you are going to reload the drilling data with the fixed tables. So you will see that right here on Leapfrog, we have the option on the drill hole data to import more, to append, or to reload the drill holes. When we want to fix the errors, as we were saying, and you are coming back this to the database, you are fixing and reloading. If you want just to input, for instance, a second phase for your program, you are going to append. Why? Because every time you reload, you are coming back from the start point that it's on your database. So if you didn't have fixed any of the errors on your database, it's going to be reloaded the errors too, and it will be necessary to do the process all over again. So now that we are on the drill holes, we are going to check our drill holes and starting by the color. So we are going to get the color and drop it. So when we see the color and drop it this way, we can just check the visualization right here. So if you click on this little cylinder right here, we could see that if it's not clicked, it can be better for us to see the visualization. But this cylinder right here is going to be pretty good for us to see the visualization of the other parts of the drill hole. Right now, we are just checking the color. And by the color, I'm just going to now put the easting look. So just seeing by the east, we could see that probably we already have we are already seeing a mistake right here. So if we double click right here, we can see that this is displaced. It's not making sense. So the OL012 is not making sense. So click on that and you will see this little window open right here. And you can click on Open Color. And this is going to lead us to exactly the place where we had that color. So now that we have this here pretty clear for us, we can also edit. So if you're already in this tab right here, and you already have this selected, the OL012, you just need to double click right here, because as you can see, this is a typo mistake. So 99, 96, and here we have 998. The right one is 698. So please correct that so you can have your error fixed too. This is the example, the first example that we are seeing from a typo. So you could see the error, and now you could attach the error to just attack where the error is. So you have changed it to 698.098. Now you just need to save it. Now that you have this saved, we can come back to our visualization. So if you want to import again the color, you can. And now it doesn't seem to have any visual problem on it. And we can just right click on it, go to fix errors, and take a look on what is happening. So what is happening right here that we still seeing these errors, we have a duplicate whole ID. So we just need to click on it, we expand everything, row, conflict, and now we are seeing exactly here the whole ID and the problem that we may be checking on it. So the problem that we are seeing right here is a duplication problem. And what we are going to do with that, we are just going to click on it and ignore it. We can save it right here. And now we can see that the errors that we had on our color were fixed. And now we can go for our other data. We're just going to close the tab of errors so we can open again. So once again, we are cleaning our screen. So screen cleaned, we now need to check our survey. So if we insert our survey right here, you can see by the tiny little cones the direction of the dip, right? And we can check right here by the visualization what it's not making sense. So what it's not making sense? This segment right here. We could just click on it, and the same way that we have done, we are going to open the survey. So now that we have opened the survey, we can just check right here what is the problem that we have with it. And we can see that we have another typo problem. So we just need to double click on it and take out the 0. So in the OL007, we just need to, on the dip, to change the angle, because we had a typo here that was 710, and we could see, visualizing that we have an error on the survey, and now we just need to save it. So the visual problem that we have on the survey was fixed. We can no longer see a problem right here. but it is still appearing as having errors. So we are going to right click on it and go for fix errors. So once we enter on the fix errors, we can see new kind of errors that we haven't seen before. So the first of it is going to be the color maximum that exceeded. So if this happens, we can just click on it and click on the fix maximum that in color table. So that's what we are going to do. We are going to click on it and click on it. And then we are going to save it. So now we don't have any errors, but we have warnings. So let's take a look on the warnings, if they really need to be fixed or not. So right here, we have a little problem on duplicate color and surveys. So what the program is telling me that we have a duplicate right here. But the problem is we don't have a duplicate. This is just a warning because this naming is very look-alike this naming right here. So the program can understand sometimes that you are committing a typo. So it's warning you to take a look on your data. So right here, we can see that this is just a warning, and this is nothing to worry about because those are two different informations right here. So we don't have duplicates on the same site. So let's just take a look now to wedge not found. So possible duplicates. And we have the same thing. We have the OL10 and the OL10W. So that means that we have two different kind of data, but the program could understand this as maybe being a typo. So this is warned for us to take a look. But we could understand that this was no important for us. This is nothing that will stop us to realizing what we need. So now we just need to save it. And then we can just click on this X. And we now just need to check on the essays and on the geology. So first of all, let's just expand the essays and expand the geology. You can see on the essays that we have the errors attached to each of the elements. So that means that we'll have to take a look on both of them. And we will see now what we are going to get when we have numbers classified as numerical data, because all the numbers that we have checked until now, they were classified as strike, zip, angle, or something that was already established for us to understand how our drilling hole is behaving. Now here we have our essays. It's just our data. So we are going to handle those problems a little bit different. If you want, we can do the same. So you can check right here on the screen, and you can already see that the problems surrounding it may have something to do with the maximum depth of it. So we just need to right click on it, fix errors, and now we are going to go for the warnings. So no sample on this color. Okay. Conflicts and data in wedge. So if we want, we could just ignore these kind of errors because they are not from the same drill hole. So you can see that this conflict and also the essays that we have some kind of issue and conflict. And we can sort all those warnings by solving the warning on the survey. So we are just going to go directly for the invalid values handling. Why? Because this is a part right here that is so important that we have those tick to give when those rules have been reviewed. So just coming back a little bit for you to understand now the part that we are on the correcting the errors. So when we have invalid values handling, this is what we are seeing right now. So we will have some common ways to fix the error and warning that is going to be for missing values, non-numerical values, or numerical values that are non-positive or infinite. We can omit, so omitting any kind of data will keep the imported data value, but will omit from being used as an input. So you will have this information there, but it will not be used to be processed. So replacing. The replacing will keep the imported data value, but will use the replace with value when it's used as an input. So this means that on your database, on your official database, you are not doing that. So remember, if you are replacing something and you are using calculations afterwards, remember to make this note on your data source too. So all those values that are not handleable, that you are replacing, you know why. And will keep all the imported data values as inputs. So you will have all of it in the same place as you have inserted. So now let's coming back to our project. Now that we have already understood a little bit what we need to do for the invalid values that we may find on the code. So we have here some missing values, and we have here some non-numerical values, and also some non-infinite values, which is great. And also we don't have any kind of problem right here that it's going to make a really difference for us. I am just checking that we have here one value occurring 38 times. So that means that we are going to replace it with 0.01, because when we are talking about this, what it's very important for us to be aware that we have here an important decision when we are talking about the calculation. So we need to review all this data, because after all, the calculation will not be right if we have any kind of those problems. So let's just go here for the copper and what we have here on the copper. So we have here non-positive values and infinite values on 0. We have non-numerical values right here. So the action that we are going to take is going to be replaced by 0.05. That is going to be the last by half. So it's actually 0.5. If you want, you can also input the less. Why? Here we are pretending that we have received this information from our laboratory. And what a laboratory is going to do? If it's not on the detection limit, it's going to input this not handleable value. And what you need to do when you are seeing this doesn't mean that you don't have copper there. This just means that it's under the limit of detection. So you can try different ways on that. You can insert the detection limits on it, depending on the geochemical handling that you are giving to it, or you can input the half of the less of the minimal number that you will have, the detection limits. So in this case right here, it will be the half of 0.01. So just just review those rules, ticking here, and going for the copper and doing exactly the same thing. So on the copper, we have 0.02. So we are going to replace it by 0.01. And this is because I have decided right here to do the classical geochemical calculation that we use the half of the detection limit. So is the smaller number that I can get from this calculation right here, from this analysis right here, is the half of it. So I have reviewed those rules, and now I just need to save it. So we have already saved our numerical part, which was very important for us to understand that we couldn't do actually any right calculation if we were not seeing that. So now that we have already done everything that was the most necessary for our essays and we just have warnings, we don't have errors anymore, we can go over to our geology. So now we just need to click to stop seeing that a little bit, and we are just going on for our geology. So we can do the same thing right here, and we can check that probably we have a problem right here on the 163 column. So we are just going to go for fix errors, and we have right here the overlapping segments. So when we have an overlapping segment, we are just going to do the same thing right here and take a look on our typos. Why? Because when we are talking about overlapping, generally we are talking about also a kind of type that can happen on the field. So if you have already logged some car holes, you can see, you know already that after a time you are a little bit tired and you can make a lot of mistakes. So those kind of errors, they are pretty common to happen. So if we check right here, the 34 has a conflict with the 35, and this is probably a typo. So we just need to change here to 43 and then save it. So we just need to change this to start where it's ending and just save it. The same thing we are going to do now for the row 6. So right here, we just need to input another 5. And then we can click on save. Now again, on the row 1, 2, 6, we have here the 0 to 7, and we have here the 0 from 10. Just let me take a look here. And we can just see it right here, the OL14A and the OL14A right here. So we could already take this from 7.52 and here 7.5. And we
Julia,
can, hello,
that was,
Arushi?
yes, I was saying that was 14 and 14A, I guess.
Oh, okay, let me see. So here on the geology, right?
Yeah.
So the overlap right here. So it wasn't this one.
See, the whole idea is 14A and the other one is 14.
Oh, you're right. So we can ignore that and just click on the saving. Why? Because this means that the program is not understanding that this is a different kind of hole. So we can just click it and save it.
But I
The
see there
same,
is one more. If you
sorry,
see the ID 128 from 2,
128.
it's given 168.5 and 175, and then at 129 it is 175. If you see that, there is one O one
One
sorry ID 127 7.5 to 17.2, then 128 is 168.5 to 175. So I think that is wrong, right?
for sure, for sure. It is.
So we need.
So, yes, we just need to make sure that this OL14, what it's going to be missing right here. Why? Because we have here from D1 into miss, right?
Yeah.
And right here, we have the D3 from miss. So what that means? That means that we may losing some information right here. So we just need to check a little bit. Let me just see the conflicting data in redrilled hole. So we have here some warnings, and the warnings we shouldn't take a look right now. So when we have a problem like this and we know that it's very specific to a drill hole, we go back to the visualization because this is going to be the best way for us to do that. So we are going just to check the OL014A. And this is going to be a great opportunity, a great opportunity for us right here to also see if we can already. I am not going to save those savings that we have done here because let's try to find this error on the scene. Because we can, it's already here, right? So if you want to check out where this is, it's the OL014A. So we have here the simple lithology and the stratigraphy. And probably because we have inserted both of them as lithologies, this is happening because there is an unmatching of things right here. So if we see it, if you want to see with the name, we could input the color and then we can see the OL14A. So let's not worry about that in this moment right now, because what is the most important here is to understand the visualization of those errors, to go check for it, and to open and fix it. But this problem that we are seeing right here, we are going to solve it a little bit further because this is about the selection that we have made of the lithology and the stratigraphy as a lithology too. So we are checking here is the two informations getting overlapped. So let's go back here to our table. Just remember that if you want to have the visualization and open the table, we can. So we can just go to the focus errors again and go for the overlapping segments, that this is what we are seeing. So conflicting data in re-drilled hole. So let's just check this. This conflict data on the redrilling hole, this is really what should be ignored. So let's save it. And now let's take a look on the overlapping segments. Why? Because here is the problem of the mismatching things that we are seeing. So let's take a look on it. So if we see here, we have the same thing that's being pointed out right here, but we have the points that Arushi had already commented with us, that we have this missing interval right here. So now that we have been very aware that we have this missing interval in this point, now let's just take a look on our data and what we could do until this moment, just because this way we can wrap it up all the day by one idea in the final segment of the class. And in this moment, we can close a little bit this part right here before the next interval. So one thing that I wanted to mention with you First, we have already made our color fixed of errors, right? So I have already commented that on the topography, we have something that is very important for us, that is to adjust the height. And how we can see that the topography must be adjusted to the height. We can input the topography right here. So in general, you will not have really big problems, but sometimes you can see a bit of an overlapping or missing data as this little drill hole right here. So if we have the drill hole data, and in our case right here, I know that my drill hole data has more accuracy than my topography. I just need now to adjust the surface height data that I have right here for my um, sorry, I just need to adjust my topography right here for my color. So what we can do, we can add height data. So we could use points and just go for the color and click on it. This is going to be very helpful for us when we have a lot of data and we need to make it everything right with the topography to have the right volumes too. Because if you leave a little gap on the surface and on your data when it's getting, you may have a problem here of missing data that it may be fulfilled in a way that you are not imagining yet. So now that we have already checked a little bit the topography, I'm just going to give the interval a little bit early at this moment because it's going to be our last interval and we can fresh up a little bit to the last part because on this last part, we are going to get to the geological model. And we are going to stop on the geological model and start tomorrow to do everything that we need to know to get a geological model that doesn't will give any geometrical problems for you on the future. So just to mention a little bit of it, the geological models right here, this file, if we right click, we can construct a new one and we will do based on an analysis that we are going to do on the drill holes of our data right here. So I will be back in 10 minutes. So if you have any kind of doubt that is not related to the error, the same one that Arushi had already comments, please tell me. I will give here 10 minutes until we have a full time. We can come back on the full hour. So just to be aware, you are all in the same place, geographically speaking. You are all in the same time zone.
Yeah, few of us have a 1.5 hour difference.
Okay.
Yeah,
So yes,
Julia.
it's just tell me.
Yeah, Julia. After this today's session, are you going to share the video with us?
Yes, yes. So the video, the content you are seeing here that I'm showing my slides to, I'm going to share that with you. I'm also going to share several articles about it. So if you are thinking like, oh, I got lost. There's too many errors to deal with. I don't remember anything. This workflow that I have shown you, I'm going to pass this all to you too. So the further informations about compositing and the ones that are a little bit trickier when we are talking about the technical part, you will always have everything available. So I will send an email by the end of each day and a final email.
Yeah, thank you. Thank you, Julia.
You're welcome. So I will be back in 10 minutes. I will not put hours here so nobody get confused. Be back. Hello, hello. I'm sorry I was a little bit late. I just need more 5 minutes to go to the bathroom. I'm sorry. But now we are back. I am here. Let's share my screen again because we now just need to fix our errors from our interval, that is our geology, so we can carry on a little bit on our on what we want to check right here in our project and how we are going to carry on with our interval selection. So now that we have already here, let's just go back to our geology. So now we are just going to go for fixing the errors, the overlapping segments, and the warnings. So on the overlap segments, we are just going for the first row, the 35, that is conflicting with the row 34. And right here, a typo that we can just make it right here. So 169.43 on the row 35. And now save it. Now the second one, we have something similar. We just need to add a 5 right here. I thought that we may have passed this, but okay. And here, and now we just need to go over because we have here the 7 and we have here the 7 also. But here it's telling us that is the same, but it's not. So we should just not take a look on that and just go for the next one. So we have here the similar case is the OL014A, and this is the OL014. So this we should not, we should just let this, and we have the same case here, and the same case here, and here. Now we just need to save it. We will still have our little error right here, but this is not going to be a problem for us in this moment. So we are just going to close it. I'm sorry, this part it's overlapping with the Teams part of the code. And now what we are going to do, we are going to start to take a look on our drilling holes and how it is behaving, because at first we were just trying to fix errors and now we are trying to actually understand what is happening. So to understand better what's happening, we are just going to import here the geology. Why? Because we have here the geology and we have here the stratigraphy. And we can input right here the stratigraphy and the simple lithology. So on the simple lithology, we have the simple way of explaining all this data. So we have the dike, the granodiorites, and we also have an overburden, a quartz porphyry, and a vein. So what that means? That means that our project is going to be separated into a dike, two dikes, a vein, porphyries, and an overburden. And if we want to take a look on this individually, let's just take a look. We could just make this a little bit bigger. We can see here the missing interval that we had. And also one thing is to editing those colors. Why? Because here we are trying to understand a little bit how this geology is behaving. So we are just going to go for our stratigraphy right here. We are going to go for editing colors, and we are going to take a look at some things. The first of it is that the granodiorite right here, it's separated into three phases of granodiorite. So what that actually means? That means that if we want to model this as one body, we will have to group it. Also, we have here a dike, and we can take a look just on this dike. how this is happening. This dike right here, we could interpret it as one, but to do so, we will need to draw two dikes, right? In the logic of what we are doing right here, in the logic of our geological model right here, this is pretty narrow. So we will have to model this as veins. So this is right the moment when we start tracing our um, that we start to trace what we're trying to get here. So in this moment, we just need to understand what are the bodies that I have and what is going to be the surface that I'm going to build to separate those bodies. So for instance, we have right here the dike. The dike is going to be one body, right? And it's probably truncated right here. So we will need to do one dike and the second dike right here, and then get them together right here. And the same is going to happen with the granodiorites, because we have right here the granodiorites, and it's separated into three. So the granodiorite, we need to group this as one, and the dike, we need to select as two different dikes that we are going to call it as veins. But we also have a vein right here, so it's important for us to make clear that our dikes are not the same as our veins. So this is our vein, and our vein should be modeled by taking this plane right here, a plane that should go right this place. And if you want to draw this plane, you can. So you can just sketch here and draw your plane. If you want to afterwards change it to make sense with your body, you can also. And just by changing here, you will change the height, and here you can expand it. And if we want to make a trend on this right here on our vein, we could already do a trend and use it. We would just need to intersect all over our segments. So this is important for us to understand how this behaving and how we are going to make this behave as we want. And now we just need to start doing what we need to do, that is to group the granodiorites and to separate, to split the dike into two. So we are going to split the dike by interval selection, that is right here on the drill holes, and we are going also to select, to group the lithology right here on the drill holes too. So now that we have already understood a little bit how it's going to happen, this part of preparing the geological model, it's because, as we can see right here, when we start a geological model, I'm going to show you new geological model, we can input the base lithology column right here. And what we have already checked, that the best one for us to input right here would be the stratigraphical one, is the more complete. But to do so, we still will have to change a little bit our drill holes. We will have to change a little bit what is happening right here. And this is going to be pretty easy. It's just about changing right here. So on the drill holes, this way we are going to do a new interval values. So we are going to import it from files. Oh, sorry, no. So right here on the geology, we will have just to do this part right here, because we can see that this is attached to the simple lithology and the stratigraphy. So right here, we are just going to do a new column, and this new column will have the group lithologies and the split lithologies and the interval selection. Why we are not going to use the split lithologies on the dikes? Because I want to show you a little bit of the editing that we can do. So we are going just first start by the group lithologies. We are just going to do this base column a new name that is going to be grouped lith. And it's going to be based on the stratigraphy, the base column. The name is going to be grouped lith, and we can just do the OK. So when we click on the OK, we can see right here everything that we want. So we are just going to take out everything that is not the granodiorites, and we are just going to click on auto group. So we are just going to do a new group, and this new group is going to be called the granodiorites. So we just need to do that by saying G and D right here. So now we just need to see everything and take this out, and we are just going to do a new group. Oh, sorry, I have, let's just go back here and discard this part a little bit, and we are just going to open again. So right here, we just need to select the granodiorites and a new group. And now we are just going to do a new group, and this new group is going to be called G and D. So now that we have the G and D as a new group, we can just take it out and build the new one by seeing everyone and auto group, one per value, new group. Oh, sorry, it's still not right. So we just need to group our lithology right here. Just a second, because we have changed it right now, the layout a little bit, and I am just missing a bit on this part of the grouping. Just give me a second. We have it right here to group the granodiorites, and just need to check on that for 1 second. Just 1 second. Because we are right here on the group and the ungrouped categories, and we just need to group the G and D. Oh, now it's done. And now we can just do a new group. This one right here, I'm just going to take it out. I'm sorry, I was just forgetting that we have also to click on it. So you just click on one and do the control, click on the other and click on the other, and then we can do just a new group. And this new group is going to be G and D. And you can see that right now we can check that this is right because we can see that the G and D are no longer here. So I'm asking sorry, it's just there was a tiny difference that we have from the other version to this one. And now we need to select everything that we want to do the grouping right. So now that we have selected the G and D, we just need to auto group the rest of it because we just need to import this as a new one, and we can do a new. You can just do the auto group one by one too, if you prefer, and then we are just going to click on the OK. So now that we have the OK for it, you can see that we have here our granodiorite separated as just one, which is very important for us because now it's making sense. So now that we have our granodiorite separated, one thing that I wanted to show you is how to do the interval selection. So now that we have done our grouped lithology right here, that it's based on our stratigraphy. So anytime that you are finding hard to remember what it's based on what, you can just come here and expand a little bit. So just coming back on the grouped lithology that we have right here, this is the one that we are checking right here on the visualization, and we can edit the colors and take everything out and just see the granodiorite, how it is. So now that we have everything done here, we can just go for the splitting. Why? Because now we need to do a new column and it's going to be an interval selection column. So this interval selection column will have the basic column as the grouped lithology. So this one is going to be the grouped lithology and interval selection lithology. And why we are doing that, we are adding columns this way with our interpretation of what is happening. So this way we can understand a little bit with more vision the steps that we are passing through. So what we could do actually, we could do everything at once, but the problem is if you don't do, you have a simple lithology and you can make it more complex by adding more information and doing the stratigraphy. And then you can add more information by grouping this stratigraphy and specific lithologies. And then you can separate some intervals that are important for you to be modulated differently. So what am I saying right here? Is that for more that it seems like we are doing a lot of steps in the same kind of data, you are still going to be using that as an interpretative tool afterwards. So now that we have done the grouped lithology as an interval selection lithology, we are just clicking on the OK. And why? Because now we are going to make more lithologies and also to assign our lithologies to our dike 1 and our dike 2. So we have the interval selection right here, and we just have it open now our editor toolbox. So this part right here, it's very important for us. Oh, sorry. It's very important for us to take a look on it and understand how to use it because it's going to be very resourceful. So at first, for us to select the intervals with a stroke, with a line. We are going to select this right here. And what is going to be the wild of this line is going to be set it right here. So if you want to make the line of interval selection bigger, you can. And you just need to do this right here. So if you want to make it smaller too, and here we can select everything at once, and here unselect everything at once. The same way I can select just one part and just invert the selection to take everything else. So now that we have already done that, we have already checked how we can do that. We can just come here on the grouped lithology because we have here our, oh, of course, we have here our visualization compromised by the editing colors that we have taken this off. So now that we have seen a little bit further of what we can do to our grouped lithologies, now let's just add our lithology right here to our interpretation grouped lithology. So at first, we will just need on the strat, just take a look on what we had, remembering you will always have um, the question mark for you to take a look a little bit on each part specifically. And now that we have already seen that this is what we are going to do to get to our geological model, we can already do our geological model right here. Why? I had shown you that we need to have exactly the stratigraphical part that we want to use it to use in our geological model. So right here, it's very important for us that we have already done the interval selection column. We can fulfill that later, but right here, what we could do is already create our geological model with this information that we have created. That is the interpretation that we have from our lithology. So we are just going to click on New Geological Model, and in the same way, we will have the boundary box. So the boundary box is very important for us to understand what is happening and what is the size of the place that we are trying to work. So we can enclose the object right here to our essay or our geology. In our case right here, we can do just for the geology or just for the essay, and we can see there is no change for it because the geology and the essay, they are attached to the same thing. And now we can call it a geological model phase 1. We can see that the surface resolution right here is set to 50, and we can input that to 30. As you can see right here, in the same way on the geological model and on the topography, we can see the option adaptive. So what that means, you can input your resolution as adaptive if you are not sure of the distance of the things that you are seeing. So this right here, it's very important for us if we are not aware of the resolution. If we are aware of the resolution, as we are right now, because we have how to measure things, right here, we can, by measuring things right here, we can set the resolution. And by setting this resolution, we could already have here a number and don't need to input as an adaptive. Also because if we have a resolution of 30 and you are trying to model a vein of 2 meters, for instance, you will have a problem. It's very probable that your data will not fit perfectly to your surfaces because you are doing something in a resolution that is way too big. So now here we are just going to put the interval selection lithology and the surface resolution of 30, enclosing the object. The name of the geological model is going to be geological model phase 1, and we just need to click on the OK. So now that we have, remember, we are only visualizing here the granodiorite because we have edited the colors just to see that. So remember, if you are not seeing things right, is because you probably are not editing the things that you want. You are not visualizing the things that you want. So now just clicking on the OK, we can check out all the informations that we had. And now we can see our model and how a model works. I wanted to get here because this way you can visualize what we are trying to get. Why? Because you are seeing the dikes, you are seeing what I'm trying to group or to split, but you may not be understanding why am I doing that. I am doing that because the geological model is a block. So why I have told that what is in the 3 most important things right here, the resolution, the boundary box, and the trends. Why? because we are going to settle the surfaces that are going to cut the solids and make the volumes out of it with the base of our boundary box, our resolution, and our trends. Because if we have here, for instance, a layer cake, we could have a model in a layer cake type, we would have something more horizontal. But if, for instance, I know that it's a lithology that it's cutting everything, I need to know if this lithology is going to be too narrow, because if it's going to be too narrow, I will have to change my resolution to fit on that. So one thing that is very important for us to be aware is what we have here, D1, D2, D3, D4, D5. If we input a little bit of transparency right here, and if I insert right here the editing colors and take off just for the D1, D2, D3, D4, we see that we probably have a stratigraphical sequence right here. So a layer cake. But this doesn't mean that I would have that the right decision would be just to cut those surfaces right here. I need to analyze the granodiorites and the dikes that I need to split right here. Because if I don't do that, there is no possible way for me to construct this model making sense. I can construct a first pass model that is not going to make actually any sense. So now that we have reached to the geological model, or basically it's, I wanted to know if we have any major doubt at this point. But first, be aware that these errors right here that we are seeing on the splitting, we are going to fix it by the start tomorrow. I think it's not morning for you there, but just let me think. And also, we are going to, tomorrow, we are going to construct the first phase, the second phase, the weathering model, and the open pit model, finishing with the combining model. So on the, we have three intervals, so it's going to be each module in one part of it. So I have tried to get started today a little bit slower for everyone getting the rhythm. So everyone, I thought that maybe here we'll have some people that still doesn't have much familiarity with Leapfrog and how the the project tree works and things, how to open and close and drag and drop and resolution, things like that. So I think that today starting a little bit slower, it's better for us. And maybe we should stop a little bit now, because if I start to talk a little bit further, we will not have time to finish for tomorrow. So I just want to check with you. You all be able to get in the same place as me in the geological model?
Julia, I was
Hello?
little Hello, hi Julia, can you hear me?
Yeah, yeah. Arushi, tell me.
This is Babita. I was little
Awesome.
stuck in between, and so I was little disconnected. So I
Uh-huh.
am little behind.
Mm-hmm. So tell me, in which part are you stuck at?
After the topography, I was little disconnected.
After the topography. Sorry, Arushi?
After the topography, I was little disconnected.
Oh, so after the topography right here.
So today you are going to share video with us, so that will be helpful.
Yes, yes. I'm going, it's just because right here from the topography, we have inserted the drill hole data, we have fixed some errors, and also we have created our geological model and started to do our interval selection right here. So I am just thinking, Arushi, maybe if you have half an hour tomorrow, and if you want to start half an hour earlier to do that part with me, we can.
Yeah, sure, sure. Yeah, that
You
makes
think it's better?
yeah, that makes sense.
So it's going to be the same room on Teams. It is the
Yeah,
same invite. You just enter 30 minutes previously, and I will be there waiting for you.
yeah, all right. Thank you. Thank you so much.
You're welcome. So if we don't have any more doubts for today, we have started as low as day. So Anzar, please.
Yeah. Hi, Julia. I want to know about the topography because today we
Sorry?
have a topography.
Yes, for
Today we
sure.
have
The top of
created from the point data. Can we create from the GIS file or not? Like we have a
uh
contour lines from DWG file or GIS file.
oh, of course. So right here on topography, we can right click on it and oh, right now I have this fulfilled. But if you had, for instance, the polylines of your contour, I'm just pretending case that you have all the contour lines, you are going to input that in polyline, you are going to import this, and from polyline, you are going to do a new mesh from polylines. And this mesh, you are going to put right here. So when you say to put here, you are going to say to import a surface data. So you are asking if you have, for instance, GIS data or points data, how you're going to input that as a topography. So you could see that the points, I could directly done the topography. But with polylines, for the curved ones, it's going to be better first do a mesh, and this new mesh is going to be from polylines, and then you are going to import for the topography. Your topography is going to be your mesh.
Okay. And the other things you have projected the color on the topography. Like
On the
this,
topo
yeah, you have projected like some drill hole are lying below the topography and some drill hole lying above the topography. When you projected the color on the topography, the like a
Mhm.
jet color, it automatically update on the drill holes.
Not necessarily. If you want to adjust the topography to the drill holes, you will have to come here to the topography, adjust hide data and points, and you will see your color right here. And you will click on your color because the color information will always be inserted as points too. So you can see right here, the color is also points information. So you can put and adapt your topography to the color, and it's going to get this way. Topography is getting topo points and color points. So this is what it's being taken account to do this topography.
Okay. Okay, thank you.
You're welcome.
Julia, one question I have.
Tell me.
Okay, so in the geology file, we can see that there is again the red sign showing the error. So
Mm-hmm.
is it okay without like we should continue without fixing? We can continue without fixing this, or we have to first fix this and then continue our work?
We need, if we were working daily on a daily basis, we need to fix this before continue working. What we have here is that I wanted to get with you the information of the volume. I wanted to make the volume for you to understand why am I trying to do those splitting and grouping and whatever I am trying to do right here. Because by the end, I'm going to show you that we can just update everything at once. So
Okay.
if I go here now, of course, if I don't start to do the surfaces, before starting to do the surfaces, if I go now and start to fixing those errors, it will be already fixed right here on the other columns that we have created. So this is something really nice from Leapfrog, that everything that it's here, it will be always updated when you do a new correction and save it.
It can be in any file, right? Like
Yeah.
suppose, okay.
Yes, and for you to check if this is going to happen or not, you are going to check right here by right-clicking in any file. You will see right here, View Relationship. And you can click on the View Relationship and you can see what was the inputs necessary to do this feature and what are the outputs from this feature. So what this means? This means that if I change this feature, what is going to be changed? So
Hmm.
here the outputs are going to be changed. So what that means? That means that if I change the OL geology, my group geology will be changed and my interval selection lithology will be changed too.
Right. Got it.
Hi,
Thank you.
Julia. This is Harish.
Tell me, Harish.
Yeah, actually, you said we can reload the drill holes. Uh,
Uh-huh.
so, so there is option for append drill holes. There is option for reload drill holes. Suppose I want
Yes.
to reload the drill holes and only the one particular file, like only lithology. So
Mm.
is it possible to upload or reload only one file, like litho only, not
Yeah,
all?
but you will need to append.
Append, okay, because I have by mistake deleted the simple lithology file. So,
No, no problem. So
I
if you
had
want,
the exact same issue.
yeah,
yeah,
no problem. So you should have told me before because this is something that can happen, will happen actually. When you are dealing with
okay,
data, with real data, sometimes you delete something that you shouldn't. And you must be aware how you're going to solve this. So in your case right here, you could go in geology and you
hmm,
could go in new column too.
okay,
And you could import column and then you are going to be back to the place where you get those columns and you're going to do the same. But in this case, you're just going to click on geology, open, and here simple lithology, you're going to select as lithology right here and click on finish.
okay. So new
And
column,
that's,
it's a new
yes,
column and import
yes,
column,
yes,
right?
yes. Sorry, I was a little bit quick. Right click, new
अभी तो चल
column,
ही रहा है.
Import
import
column
column.
and
Yes,
okay, then only geology.
exactly. On geology, and then you open,
Okay,
and
okay,
then here you select lithology, and then finish.
And like if we want to insert any column, like in a geology file, then we can insert or not.
Yes. So for instance, what I have done here, grouping and splitting the geology, was inserting new columns. So those right here, the grouped and the interval selection, they are new columns on the geology table. So if we click on the geology table, we have here open in a new tab. So we have this threads and the simple lithology that we have taken from our data sets. And this grouped lithology and interval selection that we have made. So when we can create right here a new column and can be a group lithology, a split lithology, an interval selection, an evaluated column, or a majority category from other table. Sorry, did I answer you?
Okay, okay.
And Julia, this after uploading this only lithology file, we have to fix the error again.
Yes.
Okay.
Because
Okay.
this, so let me explain this one more time, because this is very annoying sometimes. This is the difference between the reload drill holes and append drill holes. Because if you are reloading drill holes without actually making them right on your database, you are going to reload all the errors too. So when you are appending new drill holes, it's going to be what we are going to perform when we get our phase 2 new information. Because we have already fixed our phase 1, we just need to append more data on it. We don't need to reload all the data. So I know that it's kind of tricky, but one thing that can help you is the little icon, because here is already saying it's going to upload everything. Here you can add just one more thing for you.
Thanks, Julia.
You're welcome. So if anybody had further problems of getting lost today and want to join Arushi tomorrow, half an hour earlier, there is no problem, okay?
Julia, tomorrow Babita will be joining you. Like that question was from her, and she's using my laptop to like I am connected in the screens, and everybody's here, so that's why there's a confusion.
Okay. No problem. No problem at all. So also tomorrow I'll make available one project for everybody to get together in the same project too. I think it's going to be a little bit easier this way.
No,
If every
everybody is
day we
using
start.
their laptops and they're working on the laptops, but for the audio, my screen is connected.
No problem. It's just that on the laptops, for instance, because now we are very in the start. I have started pretty slow, but on the day 4, probably the day 3, maybe it's better for us all to start in the same project together. And all of those projects are going to be available for you too, along with the recordings. So the recordings, they are a little bit heavier. So I just need to check how I'm going to share with you. Probably a share file link with everything, but it's going to be a little bit heavy. Just to warn out a little bit.
I think there is an option in Teams itself that you can give access to people and they can directly download from the Teams.
It will be awesome if that works. Thank you very much. I will check if this works.
Sure.
It's going to be perfect. So if there is no more doubts, we can finish for today. And tomorrow we are going to meet again in the same hour. If you have any suggestion or something that you think it should be slower or faster, please just tell me. No problem with feedbacks. And if there is no more comments on it, we can see each other tomorrow.
Nothing from my side.
Yeah, I think we can start tomorrow.
Great, thank you.
Thanks, Julia.
Thank you, Julia.
Thank you so
Bye.
much.
Thank you very much. Bye-bye.
Bye.
Thank you. Thank you.
Thank you.